153 is on finding volume with other cross-sections. So this is when we don't have solids of revolution. So we're not going around like the x-axis or the y-axis. We don't have circular cross-sections. So the first one. Okay, and do you guys remember this equation? It says V is equal to the integral of our area equation. Okay, we're still going to use that, but now we're not going to use like pi r squared, like pi times the outer radius squared anymore. Because maybe we have a cross-section that's a triangle or a square or a rectangle or whatever. So this first one, so it says find the volume of the solid whose base is the region bounded by the line x plus 4y equals 4. So if you solve for y here, you're going to subtract your x over and divide by 4. So you get the line negative 1/4 x plus 4, which we all know how to sketch. Oh, plus 1. Dang it, I just realized that too.
Everyone gets a point?
No. So we're going to go up to 1, and then our slope is negative 1/4. So down 1 over 1, 2, 3, 4. I did just draw this on the board, so pretty obvious. All right, so we get that. I probably need to draw it a little bit bigger, actually. So let me kind of make it a little bit bigger so you can see this. All right, so here's the region, and it says our cross-sections taken perpendicular to the x-axis are semicircles. So if we're taking these perpendicular to the x-axis, what I want you to do is take your hand, and you're making cuts like this, right? So you're cutting the bread from the left to the right. Okay, so what that means is that if you draw in any kind of cross-section, we have a semicircle coming up off of this. Okay, so just as if I was creating that project that I have in the back of the room with the manila folders, you would have a little semicircle that's standing straight up. This is in 3 dimensions. Can you guys visualize it in 3 dimensions? I did a picture over here, so I made it so you can see y. The x-axis is here. So if you guys can see, we have 1, 1, 2, 3, 4. It's on its side, right? And then we have a semicircle coming up off of each of those. So you would have lots of semicircles, a whole bunch of them. Do you understand that picture? Okay, I know some of you guys are artistically challenged. You understand that it's been rotated and so on. All right, so if we talk about any cross-section, we're going to have this distance. So for the semicircle, what do we call that distance right there? It's the what of the semicircle? Diameter, correct. Okay, we don't have a height. We call it diameter. All right, so in order to find this area of a semicircle, the area of a semicircle we know is 1/2 pi r squared, right? So we need to find the r. So let's start out with the basics. So we know the diameter. And let's kind of keep some notes here. So our diameter is going to be something that involves x. How would we write that distance involving x? Yep, Nick. Yeah, it's just negative 1/4 x plus 1. It's just that height that we had, the y equals equation, right? Y equals negative 1/4 x plus 1. Just like when we did area, top minus bottom, right? Same thing. So that means our radius then is half of that, which I'm going to write as negative 1/8 x plus 1/2. So when I come up with my volume equation, the volume equation is always the area integrated. And a lot of times we had a pi that was out front, in front of our integral in our previous sections. But that was because all of them were circles. Okay, now this one is still, it involves a semicircle, so there will be a pi as well. But our area is going to be, the area of the cross-section is going to be pi r squared, but that's for a whole circle, so divide by 2. So I'm going to do pi over 2 r squared. Does that make sense? Do you guys see the setup? We'll put a dx on the end. What x values do you think we go from? Yeah, 0 to 4. Just like if we were doing area or volume or whatever. And we just find that. Okay, so you could multiply it all out and integrate. We can use Math 9 if you want to. You guys should be trying this along with me. Yeah?
Why does our formula not change even though we have multiple sizes of semicircles?
Because the size of the semicircle depends on what x is, like where you're located along the x-axis, so that's why the x is changing it. Yep. Because if x was 0, then you'd have a radius of 1/2. Doesn't make sense if you plug in 0. All right, so we get pi over 6. Did you all get pi over 6? Okay, I made it easier on myself by pulling the pi over 2 out and then integrating that on my calculator without the pi over 2. So you should get pi over 6. All right, so here's another one. So it kind of creates these like really strange shapes, right? So it says find the volume of the solid whose base is the region inside the circle, x squared plus y squared equals 9. So hopefully you guys all know how to graph that circle. It's a circle centered at 0, 0 and has a radius of 3. And now our cross sections are taken perpendicular to the y-axis. So when it says that, when you make your chops, you're taking your hand and you're chopping this way. You're chopping from the bottom to the top, right? So we're going like this. Chop, 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 chop. So when we talk about a cross section shape, I never try to draw it like on the axis because that gets confusing. We're going to have a square coming up off of that. Very confusing, right? So kind of hard to draw. But it's 3 dimensions. Imagine that square is coming up off of it. And you'd have a lot of squares. You can draw them if you'd like. Drawing too many gets a little confusing though. So I usually just draw one. And in order to find the area of a square, I do side by side, right? Side squared. Okay, so we want to know what the length of that side is. Okay, so in order to do that, we need everything like to be in terms of y, because we're taking everything perpendicular to the y-axis, which means that we're going to integrate with respect to y. Okay, so for our equation, x squared plus y squared equals 9, I need to solve so that I have x equals. So I'm going to have x squared equals 9 minus y squared. So x equals plus or minus the square root of 9 minus y squared. Yeah, Alex?
If you're trying to find it for y, why is getting x to be on 2?
Because when you plug it in, you're going to have y's. Like you're plugging in some kind of function, air quotes, not really a function. But. All right, so what's happening is we have a right side and a left side of this curve. So the right side of this curve involves positive x values. So it's going to be x equals positive square root of 9 minus y squared. And then the left side of the curve involves negative. I hate that that's dotted. Whatever, we'll go with it. So that's going to be x equals negative square root of 9 minus y squared. Alex? Just have your hand on the top of your head. All right, so question, what is the distance across? Like what's S, our side? Any ideas? Maddie Compton, do you know? Yeah, you'd have 2 times the square root part, right? Because what's happening is you're going to have the right side, which is the square root of 9 minus y squared, minus the left side, which is negative square root of 9 minus y squared, which ends up being 2 square root of 9 minus y squared, which kind of makes sense, right? It's the same on both sides. There's 2 of those. So when we put this into our volume equation, we're going to have that side, which is 2 square root of 9 minus y squared, and we're going to square it. And what y values do we go from? Negative 3 to 3, exactly. So if we were cleaning it up a little bit, we could do negative 3 to 3, and then we'd have a 4, which I'll put on the outside. And then I'm going to have 9 minus y squared dy. And you can even make it a little bit easier using symmetry. If you use symmetry, what could you do? Yeah, you could put an 8 on the outside and then do 0 to 3, 9 minus y squared dy. And that would be really easy to integrate because you'd be plugging in zeros for the second part of it. Does that make sense? So that would be using symmetry. Okay, so if we do that, then we get our final answer. Has anybody done it? I think I got 144. Did you guys get 144? I don't remember that number from earlier though, so check it for me. Yeah, I think that's right. All right, does that make sense? Do you guys understand that? Okay. Okay, so the next one. So this one has multiple parts. So number 3 says find the volume of the solid in which the base is the region bounded by the graphs of f of x equals, I'm going to write it like in the form y equals mx plus b. So it's going to be negative 1/2 x plus 1. So I'm going to start at 1 and my slope is going to be negative 1 over 2. So that's my f of x equation. And then my g of x equation, if I write it in the form y equals mx plus b, I get 1/2 x minus 1. So I go up 1 and over 2. So it's bounded by those two lines and then also x equals 0. So here's the region that we're talking about. So for this, we're going to have cross sections perpendicular to the x-axis are squares. So when we say perpendicular to the x-axis, that's when we're integrating with respect to x. So we're going to have some kind of cross section, and then coming up off of it, we have a square. So you can do your s by s if you want, just like the last one. So any ideas what s is going to be? It's not hard. Top minus bottom, right? So f of x minus g of x. Do you guys all see that? So let's find what that is. So I'm going to have negative 1/2 x plus 1, and then I'm going to subtract out 1/2 x minus 1. So I have negative 1/2 x minus another 1/2 x, so I get negative x, and I have 1 minus a negative 1, so I get plus 2. So negative x plus 2, or you could write it as 2 minus x if you want. Do you all see that? So that's the distance. Wherever your x is located, it's going to give you the height of that square, or the side of the square. So your area that we're going to integrate is going to be side squared, right? Because it's a square. So we're going to have our 2 minus x, and we're going to square it. So you can FOIL it out if you want to, but I would just probably put it into the volume equation. So I'm going to integrate my area. So I'm going to integrate 2 minus x squared, and my x values are going to go from 0 to 2. Did you guys see that was 2? And you can FOIL it out, and you could easily do this by hand or with a u substitution if you didn't want to FOIL. Gain a negative though, don't forget that. So this answer is going to be 8/3. Okay, can you guys kind of visualize what the shape would look like? It would be one where there would be like 2 ridges along the top, right? Do you guys kind of see that? So you'd have a base that's a triangle, and then you'd have all these like squares coming up off of it, and so it would be like ridges, like 2 straight lines on the top, kind of like a roof. I don't know. I guess I've lost my website that I was using. All right, so the next up. So this is the same base. So you're still going to do your negative 1/2 x plus 1 and your 1/2 x minus 1. So we're going to go ahead and sketch out that same base. So we have our f of x line and we have our g of x line. And we're still in this little area here. But now we have a semicircle coming up off of this. And again, it's perpendicular to the x-axis. It's going to look like that. Can you guys see that? Let me get rid of the shading. Maybe that will help. Oh, got rid of everything. So we have kind of this little semicircle shape coming off. Okay, and that semicircle is going to have a diameter, and we'll need to find the radius after we find the diameter. So our diameter ends up being exactly the same as what that side was before. Do you guys see it? It's still f of x minus g of x, top minus bottom, which is going to be 2 minus x. Do y'all see that? Do I need to write out all the steps? Same. So that means your radius of the semicircle is going to be half of that. So I don't care how you do this. You could do 1/2 of 2 minus x and leave it like that. And then when you square it, you'll have 1/4 of 2 minus x squared. Or you can bring the 2 into both pieces. It doesn't matter. So your volume then is going to be, for a semicircle, its area involves 1/2 of pi r squared, right? So I'm going to have a pi over 2. And then I'm going to have my r squared. So I'm going to do 1/2 of 2 minus x, all of that squared. So if I was making this as simple as possible, if I was integrating by hand, I would pull that pi over 2 out. But what other constant would I pull out to the front? Not 1/2. What do I pull out? 1/4. Do you guys all see that? Because you're going to square that as well. And then you would have 2 minus x squared left on the inside. So we actually did the 2 minus x squared already from 0 to 2. We did that on the last problem. That ends up being 8/3. So we have pi over 8 times 8 over 3. So I believe our answer should be pi over 3. Okay, everybody with me on that one? All right, and then C, it says the cross-sections perpendicular to the x-axis are equilateral triangles. So for this, same idea. Start it with your F and your G. And now we have equilateral triangles coming up off here, which is always hard to draw. This kind of looks like it's just there. Let me draw it a little slanty. Okay, so those are equilateral triangles. Now, when I teach geometry, I haven't taught geometry in a long time, but I always make people learn the area of an equilateral triangle. Does anybody in this class know the area of an equilateral triangle? What's the formula?
Well, I know it's like, crap, it's on the area.
Just a normal triangle would be 1/2 base times height, but there's a quicker way of doing it. Yeah, you split it in half, you come up with your 30, 60, 90. Anybody? No one knows the formula. Man, so sad. Let me draw it out. So there's, all of these sides are the same, side by side by side, right? So I'm going to call that S. All right, and you do what Maddie's saying, you drop something down, so you end up getting 30, 60, 90 triangles. All right, so we have S is along the bottom. So this distance right in here is 1/2 of S, or S over 2. Do you see that? From here to here. Okay, what's the hypotenuse over here? What's this going to be? S, which makes sense, right? Because it's S by S by S. All right, and then the last part we need is that for the 30, 60, 90, what do I multiply by? What do I multiply the base by? Root 3, right? So it's going to be 1/2 S times root 3. So this will be root 3 over 2 S. So the area of an equilateral triangle ends up being 1/2. The base, the whole bottom is S. And then the height is root 3 over 2 S. Kenzie, can you close that door, please? They just keep getting louder. All right, root 3 over 4 S squared. Do you all see that? So if you know that right away, it's really convenient, right? Especially for the project that you guys are going to be doing with the little manila folders. So let's just go ahead and we'll do a little circle, and we'll put a little star next to that. Know that. Okay, so we have these cross sections perpendicular to the x-axis are equilateral triangles. So we're still integrating with respect to x, and our x values go from 0 to 2. But the area of an equilateral triangle we said was root 3 over 4 s squared. So what is s in our case? Still just 2 minus x, right? Because it's going to be the f of x minus g of x. It's still just this height right here. That's all we're finding, top minus bottom, f of x minus g of x. So it ends up simplifying to 2 minus x. So we're going to have 2 minus x squared. So again, we've already found that the integral of 2 minus x squared from 0 to 2, that was 8/3. So our answer ends up being 2 root 3 over 3, because the 8 and the 4 reduce down to 2. That's it. All right, so any questions on any of this? So some of them, I mean, you might have perpendicular to the y-axis. You might have to solve for x, like x equals a bunch of stuff with y, right? Pay attention to that. If you are integrating with respect to y, you're going from bottom y value to top y value. But yeah, you're just basically finding the areas of these different shapes. So you could have semicircles, rectangles, squares. There's lots of different things you could have, okay? A lot of times the rectangle ones will be like where the height is twice the length of the base or something. So you would find the length of the base and then multiply by 2. So yeah, these are always on the pre-response questions, so these are good things to know. All right, let me stop.